Hi, my name is Brian. Welcome to another video on derivatives. In this video, we are going to find the equation of a tangent line on the function 1 over x at x equals 1/2. Let's go ahead and draw a picture of what's going on. So we have the x and y axis and the function 1 over x. Okay. And at the point, so I said x is 1/2, and so that would make the y value 2. Okay. And I want to find the equation for the tangent line. Now that tangent line is this line right here. So my final answer, what I'm looking for, is this line in the slope-intercept form. Question mark there. So we're going to start doing this by looking at the secant lines. Now a secant line is a line that connects 2 points on a graph. So that could be, let's try this point, which will always be this point, because that's the one where the tangent line is, and some other point on the graph, which we'll take right here. Now this one isn't fixed, so I'm just going to call that x. And so our secant line is going to be this line. Okay. Now you can see that the slope of this secant line, or just that secant line in general, is going to look somewhat similar to the secant line, or the tangent line right here. Now the idea is that I'm going to calculate the slope of this secant line, and if I can choose x values closer and closer to 1/2, then this secant line is going to become this tangent line. So I actually have a little demonstration which you can see right now. All right, let's take a look at the function 1 over x. Now what I'm going to do is show you the tangent line, which we have right here at the point 1/2 comma 2. And then let's set up the secant line. So I have the secant line connecting the point 1/2 comma 2 to this point over here, which I have a little slider up here that says x equals 2. You can see that it is set up as x equals 2. Now what's going to happen is, as the point x, this point again down here, as it gets closer and closer to the x value of 1/2, you can see the secant lines are getting closer and closer to the tangent line. So as x gets extremely close, you won't be able to see the difference between the secant line and the tangent line. Now if we take a look at the slope, right now when x is 2, it starts at -1. As it moves closer, you're going to see that the slope starts getting really, really close to -4. Okay, so what was happening in that video was that I had 2 points. We had the point here, x, f of x, and then the point up here, a, f of a. And the slope of that line is then going to be f of x minus f of a over x minus a. So that's the slope of the secant line. You then saw as x approached the 1/2, those secant lines converged with the tangent line, and that would be the same thing as taking the limit as x approaches the a. Okay, so this would be the slope of the tangent. Okay, so let's put in the specifics now. We have the limit as x approaches 1/2. Now f of x is 1 over x. F of a, well, this is f of 1/2, which we said was 2. And then x minus 1/2. And you see that when I plug in 1/2, I'm going to get 0 over 0. So there were previous videos talking about how to deal with limits when you have 0 over 0. So in this case, the technique that we want to do is to clear these. Well, there's only one denominator up here, but it is a complex fraction. You have a denominator inside of another bigger fraction. So I am going to multiply top and bottom by the common denominator of these. Now this is really just 2 over 1. So the common denominator between x and 1 is just x. So I'm going to do top and bottom by x. That allows me to multiply this x onto here, which when you do that, x times 1 over x is just 1. And then x onto 2 makes -2x. On the bottom, you're going to leave that alone. Remember, the goal is to get rid of the x minus 1/2, because that's what's making the denominator 0. So leave the x minus 1/2 alone. Again, x is approaching 1/2. Now that I've cleared the denominators, I want to be able to cancel this with what's up here. Now, I need to have a factor of x minus 1/2 come out. You may not be able to see it right now, but what you can do is factor out -2. If you do that, let's factor out -2. This is now going to be minus 1/2, and this will be plus x. On the bottom, x minus 1/2 and the x. Now you can see that you have the -1/2 plus x. It will cancel with the x minus 1/2. These actually are the same thing, so I will just cross those out. And then what's left, squeeze that in here, we have the limit -2 over x. As x approaches 1/2. Okay, and then I can let x be 1/2. So you get -2 over 1/2. Answer is -4. Now that's just the slope of this tangent line. Now I actually have to find the equation of the line. The easiest way of doing that is to do the point slope formula. So let me go ahead and erase this. Okay, the point slope formula is just a formula we use to find the equation of a line given a point and a slope. So for the point, we have the point 1/2, comma 2, and then for the slope, we found through the limit that was -4. All right, so the formula is as follows. We have y minus y1, and then m x minus x1. Now m is the slope, x1, y1 is the specific point, so that gives us y minus 2, -4, x minus 1/2. And then you just have to clean that up and put it in slope-intercept form. When we do that, we'll distribute the -4. So you're going to get -4x. Now this is going to be a positive 2, and then I'm going to add another 2 over, so it's going to simplify to +4. And this is then the equation of that line. All right, thanks for watching. Hope this helps. Good luck.